ये है DNF ब्लॉक एलिमेंट। इसमें देखेंगे आफ्टर स्टडिंग दिस यूनिट यू विल बी एबल टू लर्न द पोजीशन ऑफ DNF ब्लॉक एलिमेंट इन द periodic table, know the electronic configuration of the transition D block and the inner transition F block element, appreciate the relative stability of the various oxidation of state in terms of the electrode potential value, describe the preparation and the property of structure and the usage of the some important compounds such as the K2Cr2O7, K1O4, understand the general characteristic of the D and the F block element and the general horizontal and the group trends in them, describe the property of the F block elements and give a comparative account of the lanthanoids and actinoids with respect to their electronic configuration, oxidation state and the chemical behavior। तो डी एंड एफ ब्लॉक एलिमेंट है, इसमें अब इसका आंसर ही देखते हैं। तो यहाँ कहते हैं डी ब्लॉक द, इसमें आता है कहते हैं डी ब्लॉक ऑफ द पीरियोडिक टेबल। The D block of the periodic table contains the elements of the group 3 to 12 in which the orbitals are progressively filled in each of the four long periods. The F block consists of the elements in which the 4f and the 5f orbitals are progressively filled. They are placed in a separate panel at the bottom of the periodic table. The names transition metals and the inner transition metals are often used to refer to the elements of the D and the F block respectively. There are mainly four series of the transition metals: 3D series scandium to the zinc, 4D series yttrium to the cadmium, 5D series lanthanum to the hafnium and to the mercury, and 6D series which is actinium and the elements from the rutherfordium to the Cn. The two series of the inner transition metal, 4F C to the Lu and the 5F TH to the Lr, are known as the lanthanoids and the actinoids respectively. Originally, the name transition metals might derived from the fact that their chemical property bear transitional between those of the F and the P block element. Now, according to the IUPAC, transition metals are defined as the metals which have incomplete d subshell either in the neutral atom or in their ions. Zinc, cadmium, and mercury of the group 12 have full D10 configuration in the ground state as well as in the common oxidation state, and hence are not regarded as a transition metal. However, being the in a member of the 3D, 4D, 5D transition series respectively, their chemistry is studied along with the chemistry of the transition metals. The presence of the partially filled D or the F orbital in their atoms make transition elements different from that of the non-transition element. Hence, transition elements and their compounds are studied separately. However, the usual theory of the valence phase applicable to the non-transition elements can be applied successfully to the transition elements also. फिर आता है कि various precious metals such as the silver, gold and the platinum and industrially important metals like the iron, copper and titanium belong to the transition metal series. In this unit, we shall first deal with the electronic configuration, occurrence and the general characteristic of the transition element, with the special emphasis on the trends in the property of the first row 3D transition metal, along with the preparation and the property of the some important compounds. This will be followed by the considerations of the certain general aspects such as the electronic configuration, oxidation state and the chemical reactivity of the inner transition metals. तो सोल्व एग्जाम्पल से क्वेश्चन है जो आते हैं, और 2024 में भी सोल्व एग्जाम्पल से प्रश्न है जो आया था। इसके बाद फिर है कि द ट्रांजिशन एलिमेंट्स डी ब्लॉक पोजीशन इन द पीरियोडिक टेबल। तो इसमें आता है कि द डी ब्लॉक ऑक्यूपाई द लार्ज मिडिल सेक्शंस ऑफ द पीरियोडिक टेबल फ्लैंकेड बिटवीन एफ एंड पी ब्लॉक इन द पीरियोडिक टेबल। द डी block of the penultimate energy of the level of the atom receive electrons giving rise to the four rows of the transition metals, that means the 3D, 4D, 5D and the 6D. All these three of the transition elements are shown in table 4.1. फिर आते electronic configuration of the D block elements। तो in general the electronic configurations of the outer orbital of these elements is n-1 d1 to 10 nf1 to 2 except for the pd where its electronic configuration is 4d10 5s0। तो pd का 4d10 5s0 होता है electronic configuration। The n-1 stand for the inner d orbitals which may have 1 to 10 electrons and the outermost nf orbital which may have 1 or 2 electron. However, this generalization have several exceptions because of the very little energy difference between the n-1d and the nf orbital. Furthermore, half and the completely filled sets of the orbitals are relatively more stable. A consequence of this factor is reflected in the electronic configuration of the Cr and the Cu in the 3D series. For example, consider the case of the Cr which has 3D 5 4f1 configuration instead of the 3D 4 4f2. The energy gap between the two sets 3D and the 4f of the orbital is small enough to prevent electron entering in the 3D orbital. Similarly, in the case of the Cu, the configuration is 310 4f1 and not 389 4f2. The ground state electronic configuration of the outer orbitals of the transition elements are given in table 4.1. अब यहाँ पर है इलेक्ट्रॉनिक कन्फिग्रेशन ऑफ द आउटर ऑर्बिटल्स ऑफ द ट्रांजिशन एलिमेंट्स ग्राउंड स्टेट में। तो 3D का दिया हुआ है। स्कैंडियम फर्स्ट सीरीज है स्कैंडियम, टाइटेनियम, वेनेडियम, क्रोमियम, मैग्नीज, आयरन, कोबाल्ट, निकेल और जिंक। तो जिंक का और 4f 3D तो 2 1 2 2 2 3 2 1 हो गया, फिर 2 2 हो गया, 2 3 2, फिर इसका आता है 1 5 21 22 23, फिर इसका आता है 15, फिर इसका 25, फिर 26 27, इसका खाली 1 5 है, 15 है, फिर इसका इधर 28, फिर 1 और 10 ये इसका आता है, और इसका आता है 2 और 10। इस प्रकार से है जो है। बाकी सबका जैसे एटॉमिक नंबर उसका जैसे 21 तो 21, 22 22, 23 23, लेकिन इसका है जो 15 है 4s1 3d5। ठीक है, 4s1 3d5, तो ये एक एक्सेप्शन में आता है 4s1 3d5, मतलब थोड़ा सा अलग है, एक्सेप्शन तो नहीं कहेंगे लेकिन कह सकते हैं कि थोड़ा सा है जो इसका अलग है ये वाले का। इसके बाद फिर है एमन का 25 25, फिर आयरन का 26, तो ठीक है बिल्कुल सही, कोबाल्ट का 27 और निकल का 28, और कॉपर का फिर यहाँ पर आता है, कॉपर वाले का फिर यहाँ पर आके हो जाता है 110, यानी कि इसका भी 29 होना, 2 9 होने चाहिए लेकिन 110 है, 110 एक चला गया उसमें, 2 9 की जगह 110 हो गया, और इसका 210 होता है फिर जिंक वाले का। इसका होना चाहिए था, इसका कितना होना चाहिए था, इसका 2 4 होना चाहिए था, लेकिन एक चला जाता है तो 1 5, 2 4 की जगह 1 5 हो जाता है, ये है। इसके बाद फिर सेकंड सीरीज में देखते हैं, 4D सीरीज है, इसमें आ गया वाई इटेरियम का 39, तो 21, फिर इसका 22, ठीक है कोई दिक्कत नहीं है, 21 है, फिर इसका 22 है, फिर इसका है जो 14 हो जाता है, 41 का 41 है, 39 है तो 21, 40 है तो 22, फिर 41 है तो 1 4, 42 है तो 1 5, फिर 43 है तो 1 6, और 44 1 7, फिर 1 8, फिर 0 10, यहाँ पर है जो 0 10 है, फिर यहाँ पर 47 का 1 10 हो गया, यहाँ पर 1 10 होना, यहाँ पर 1 9 होना चाहिए था लेकिन 0 10 हो गया, फिर Ag का 1 10 और कैडमियम का 2 10 आता है। ठीक है, इसके बाद फिर आता है 3D फ्रिज, 5D फ्रिज में 57 का आता है 21, ठीक है, इसका 22, फिर इसका 23 24 25 26 27, कोई दिक्कत नहीं बिल्कुल जैसे होना चाहिए वैसे। इसके बाद फिर 1 9 आ जाता है, और फिर इसका 1 10 आता है, और इधर 2 10 आ जाता है, तो यहाँ पर 1 9 है जो आ गया, जबकि यहाँ पर 1 9 है जो नहीं आया था। फिर यहाँ पर 53 में देखें तो 89 वाले का 21 22 23 24 25 26 27, मतलब सही गया अभी तक, 28, फिर 1 10 RG का 1 1, और फिर स्क्रीन का 2 10 आता है। तो इस प्रकार से है द इलेक्ट्रॉनिक कन्फिग्रेशन। और यहाँ पर जो है वाई, ये देख लेते हैं, इसमें जो 4D में आता है बाई जेडर NB, यारी जरा निभाओ मौत तक, रुकावट राह पड़े तो रुकावट राह पड़े आग में कूद जा। उसके बाद फिर यहाँ पर है कि ला हफ्ता वरना रे ऑफिसर ईरानी पीटेगी और हंसेगी। और फिर इधर आता है एक्टिनियम AC RF DB FG BH HF MT DF RG और CN। इसके बाद फिर आता है कि the electronic configuration of the outer Zn CD Hg and Cn are represented by the general formula n-1 d10 nf2. The orbitals in these elements are completely filled in the ground state as well as in their common oxidation state. Therefore, they are not regarded as the transition elements. The d orbitals of the transition elements protrude to the periphery of an atom more than the other orbitals, that means s and p. Hence, they are more influenced by the surrounding as well as atoms or molecules surrounding them. In some respect, ions of a given dn configuration n बराबर 1 to 9 have similar magnetic and electronic configuration. With partially filled d orbital, these elements exhibit the certain characteristic properties such as display of the variety of the oxidation state, formation of the colored ions, and entering into the complex formation with a variety of the ligands. The transition metals and their compounds self with the catalytic property and the paramagnetic behavior. All these characteristics have been discussed in detail later in this unit. फिर इसके बाद कहता है कि there are greater similarities in the property of the transition elements of the horizontal rows in contrast to the non-transition elements. However, some group similarity also exists before first study the general characteristic and their trends in the horizontal rows, particularly 3D row, and then consider some group similarities. तो यहाँ पर एग्जाम्पल 4.1 दिया हुआ है और इस तरह का एग्जाम्पल जो है सॉल्व एग्जाम्पल सबको बहुत ही पूछता है. तो पहला फॉर एग्जाम्पल ऑन भाट ground can say that scandium Z/21 is a transition element but zinc Z/30 is not. On the basis of the incomplete flat d orbitals in the case of the scandium atom in the ground state 3d1, it is regarded as a transition element. On the other hand, zinc atom has completely flat d orbital 310 in its ground state as well as in the oxidized state, hence it is not regarded as a transition element. उसके बाद फिर आता है इंटेक्स क्वेश्चन है कि सिल्वर एटम हैज कम्प्लीटली फ्लैट डी ऑर्बिटल 410 इन द ग्राउंड स्टेट. हाउ कैन यू से दैट इट इज ए ट्रांजिशन एलिमेंट. अब नेक्स्ट है वी विल डिस्कस द प्रॉपर्टी ऑफ द एलिमेंट ऑफ द फर्स्ट ट्रांजिशन सीरीज ओनली इन द फॉलोइंग सेक्शन. तो जनरल प्रॉपर्टीज ऑफ द ट्रांजिशन एलिमेंट्स डी ब्लॉक. तो फिजिकल प्रॉपर्टीज में आता है कि nearly all the transition elements display the typical metallic properties such as the high tensile strength, ductility, malleability, high thermal and the electrical conductivity, and the metallic luster. With the exceptions of the Zn, Cd, Hg and the Mn, they have one or more typical metallic structure at the normal temperature. और यहाँ पर एक टेबल दिया हुआ है. तो इसमें ये ग्रुप 6 का है जो टेबल दिए हुए. तो स्कैंडियम का HCP BCC आता है, टाइटेनियम का HCP BCC आता है, दोनों का सेम है. वेनेडियम का BCC आता है, क्रोमियम का BCC, मोलिब्डेनम का BCC और वोल्फ्राम तीनों का है जो BCC है. उसके बाद फिर Mn का है जो कुछ नहीं है, BCC CCP है, और Fe का है जो BCC HCP है, CCP HCP है, Ni का है जो CCP है, Fu का CCP है और Zn का कुछ HCP है. फिर D10 हो गया ये. फिर बाई का HCP है BCC और वाई का जो हो जाता है वो आता है HCP BCC. जेडर का होता है HCP BCC, NB का होता है BCC. फिर मोलिब्डेनम और क्रोमियम, क्रोम और बाला तीनों का BCC ही है खाली. इसके बाद फिर TC का आता है HCP, RU का HCP, RH का CCP, PD का CCP, AG का CCP, CD का है जो HCP आता है. और फिर आता है LA का आता है HCP CCP और BCC, HF का HCP BCC, TA का BCC, फिर RE का HCP, OF का आता है HCP, IR का CCP, PT का CCP, AU का CCP और HG का कुछ नहीं आता है. अब यहाँ पर दिया हुआ ट्रेंड्स इन द मेल्टिंग पॉइंट ऑफ द ट्रांजिशन मेटल. तो करोर, मोल, बाला ये सबसे ऊपर में आता है. फिर मैग्नीज का सबसे नीचे है यहाँ पर इसमें. और यहाँ है जो TC का है जो सबसे कम आता है, डीप आता है इन दोनों जगह पर. तो 3D फ्रीज में Mn, 3D फ्रीज में सबसे कम Mn है. तो उसके बाद फिर Fe आता है, फिर आता है V यानी कि वेनेडियम, फिर आता है क्रोमियम. तो क्रोमियम तो सबसे ज़्यादा होगा इन 3D में. उसके बाद फिर उसके बाद आप कुछ और देखते हैं जैसे ट्रांजिशन मेटल्स. मैक्सिमम मेल्टिंग पॉइंट जो होता है, मैक्सिमम मेल्टिंग पॉइंट किसका है, तो क्रोर मोर वाला का है और ये वाला फ्रिज का है. इसके बाद फिर आगे देखते हैं. तो आगे है कि द ट्रांजिशन मेटल्स विद द एक्सेप्शंस ऑफ द Zn, Cd and Hg आर वेरी हार्ड एंड हैव लो volatility and have low volatility. Their melting and the boiling points are high. Figure 4.1 depicts the melting point of the transition metal belonging to the 3D, 4D and the 5D fridge. The high melting point of these metals are attributed to the involvement of the greater number of the electron from the n-1d in addition to the nf electron in the interatomic metallic bonding. In any row, the melting point of these metals give metals right to a maximum of D5 except for the anomalous value of the Mn and Tc. तो Mn and Tc का जो है कम है. टेक्नीशियम और मैग्नीज का है जो कम हो जाता है D5 होने के बावजूद भी. And fall regularly and the atomic number increases. They have high enthalpy of the atomization which are shown in the figure 4.2. The maxima at about the middle of each series indicate that one unpaired electron per d orbital is particularly Mn और Tc पर melting point बहुत है जो dip करता है. Particularly favorable for the strong interatomic interaction. In general, greater the number of the valence electron, stronger the resultant bonding. Since the enthalpy of the atomization is an important factor in determining the standard electrode potential of a metal, metals with high enthalpy of atomization, that means very high boiling point, tend to be noble in their reaction later for the electrode potential. Another generalization that may be drawn from figure 4.2 is that the metals of the second and the third stage have the greater enthalpy of the atomization than the corresponding elements of the first stage. This is an important factor in accounting for the occurrence of the much more frequent metal-metal bonding in the compound of the heavy transition metals. अब यहाँ पर दिया हुआ एटॉमिक नंबर, इधर दिया हुआ डेल्टा H किलो जूल पर मोल. तो 3D का हो गया, 4D का हो गया, 5D का हो गया. यहाँ पर वेनेडियम है, ये हो गया Mn और यहाँ पर हो गया Tc, फिर यहाँ पर जिंक हो गया, फिर यहाँ पर Ar हो जाता है। और इधर दिए हुए है कि ग्रेटर द नंबर ऑफ द पेयर अनपेयर्ड इलेक्ट्रॉन, ग्रेटर विल बी द इंटर-एटॉमिक इंटरेक्शन, स्ट्रॉन्गर विल बी द मेटेलिक बॉन्डिंग और हायर द एंथैल्पी ऑफ द एटमाइजेशन। तो ट्रेंड्स इन द एंथैल्पी ऑफ द एटमाइजेशन ऑफ द ट्रांजिशन एलिमेंट्स है जो दिखाए हुए है। अब इसका आगे बात करते हैं वेरिएशंस इन द एटॉमिक एंड द आयोनिक साइज ऑफ द ट्रांजिशन मेटल्स की। तो इसमें है कि in general ions of the same charge in a given series show progressive decrease in the radius with the increasing atomic number. This is because the new electron enters a d orbital each time the nuclear charge increases by the unity. It may be called recall the fielding effect of the d electron is not that effective. Hence the net electrostatic attraction between the nuclear charge and the outermost electron increases and the ionic radius decreases. The same trend is observed in the atomic radii of a given series. However, the variation between the series is quite small. An interesting point emerges when the atomic size of one series are compared with those of the corresponding elements in the other series. The curves in the figure 4.3 show an increase from the first 3D to the second 4D series of the elements, but the radii of the third 5D series are virtually the same as those of the corresponding numbers of the second series. This phenomenon is associated with the interventions of the 4f orbital, which must be filled before the 5D series of the elements begin. The filling of the 4f before the 5D orbital results in a regular decrease in the atomic radii called lanthanide contraction, which essentially compensates for the expected increase in the atomic size with increasing atomic number. The net result of the lanthanide contraction is that the second and the third D series exhibit the similar radii, Z by 160 picometer, HF by 159 picometer, and have similar physical and the chemical property much more than that expected on the basis of the usual family relationship. फिर यहाँ पर दिया हुआ स्कैंडियम, टाइटेनियम, वैनेडियम, क्रोमियम, मैग्नीज साइज डिक्रीज हो रहा है, और Fe को और Na का साइज है जो इधर, फिर उसके बाद एक जैसा है, फिर कॉपर और जिंक तो साइज इंक्रीज ड्यू टू द इंटर इलेक्ट्रॉनिक रिपल्सन के कारण। और ये वाला स्टेटमेंट फिर 21 में है जो सवाल पूछा गया था। फिर यहाँ पर दिखा हुआ एटॉमिक रेडियस है, तो 3D का छोटा होता है 4D से, और 4D 5D का फिर जो बराबर होता है लगभग। तो ट्रेंड्स इन द एटॉमिक रेडियस ऑफ द ट्रांजिशन एलिमेंट्स से जो दिए हुए, यहाँ पर फिर आता है कि द फैक्टर रिस्पॉन्सिबल फॉर द लैंथेनाइड कॉन्ट्रैक्शन इज समवट सिमिलर टू दैट ऑब्जर्व्ड इन एन ऑर्डिनरी ट्रांजिशन series and is attributed to the similar cause. That means the imperfect fielding of the one electron by another in the same set of the orbital. However, the fielding of the one f4f electron by the another is less than that of the 1d electron by the another, and had the nuclear charge increase along the series. This is there is fairly regular decrease in the size of the entire 4fn orbital. The decrease in the metallic radius coupled with the increase in the atomic mass results in a general increase in the density of these elements. Thus, from the titanium Z by 22 to the copper Z by 29, the significant increase in the density may be noted. Next है electronic configuration and some other property of the first series of the transition elements. अब इसके बाद यहाँ पर दिखा हुआ एटॉमिक नंबर कॉपर का, और दिया हुआ एक्सटर्नल इलेक्ट्रॉन पोटेंशियल और डेंसिटी है जो दिखाया हुआ है। फिर से फुल एग्जाम्पल यहाँ पर अब कॉपर का दिखा हुआ है। अब यहाँ पर मेन ये था कि कॉपर का है जो सबसे ज़्यादा है, प्लस में 0.34 है, और स्टैंडर्ड इलेक्ट्रॉन पोटेंशियल और डेंसिटी तो नहीं, लेकिन स्टैंडर्ड इलेक्ट्रॉन पोटेंशियल कॉपर का है जो प्लस 0.34 है। बाकी इस चार्ट को है जो थोड़ा देर के लिए देख सकते हैं। अब इसके बाद नेक्स्ट फिर आता है एक फुल एग्जाम्पल है कि वाई डू ट्रांजिशन एलिमेंट्स exhibit the high enthalpy of the atomization because of large number of the unpaired electrons in the atoms. They have a strong interatomic interaction and strong bonding between the atoms resulting in the high enthalpy of the atomization. फिर दूसरा इंटरेस्ट क्वेश्चन है कि इन द सीरीज जेड स्कैंडियम Z by 21 to the जिंक Z by 30 the enthalpy of the atomization of the zinc is the lowest, that means 26 किलोजूल पर मोल भाई। अब बात करते हैं आयोनाइजेशन एंथैल्पीज का। तो इस स्टेटमेंट जो अभी देखने वाले हैं इससे जो 23 में क्वेश्चन आया था कि there is an increase in the ionization enthalpy along each series of the transition element from the left to the right due to an increase in the nuclear charge which accompanies the filling of the inner d orbital. Table 4.2 gives the value of the first three ionization enthalpy of the first series of the transition element. These values show that the successive enthalpy of these elements do not increase as steeply as in the case of the non-transition element. The variation in the ionization enthalpy along the series of the transition element is much less in comparison to the variation along a period of a non-transition element. The first ionization enthalpy in general increases, but the magnitude of the increase in the second and the third ionization enthalpy for the successive element is much higher along a series. फिर आता है कि द irregular trend in the first ionization enthalpy of the metals of the 3D fridge, though of the little chemical significance, can be counted by considering that the removal of the one electron alters the relative energy of the 4s and 3D orbitals. You have learned that when the d block elements form ions, ns electrons are lost before n-1d electrons. As we move along the period in the 3D fridge, we see that nuclear charge increases from the scandium to the zinc, but electrons are added to the orbitals of the inner subshell, that means the 3D orbitals. These 3D electrons fill the 4s electron from the increasing nuclear charge somewhat more effectively than the outer shell electrons can fill one another. Therefore, the atomic radii decrease less rapidly. Thus, the ionization energy increases only slightly along the 3D fridge. The doubly or more highly charged ions have DN configuration with no 4s electron. A general trend of the increasing value of the second ionization enthalpy is expected as the effective nuclear charge increases, but because one d electron does not shield another electron from the influence of the nuclear charge because d orbitals differ in the direction. However, the trend of the steady increase in the second and the third ionization enthalpy breaks for the formations of the Mn2 plus and the Fe3 plus respectively. In both the cases, ions have d5 configuration. Similar breaks occur at the corresponding elements in the latter transition series. The interpretations of the variation in the ionization enthalpy for electronic configuration is Dn is as follow. The three terms responsible for the value of the ionization enthalpy are the attractions of the each electron towards the nucleus, repulsion between the electrons, and the exchange energy. Exchange energy responsible for the stabilization of the energy of state. Exchange energy is approximately proportional to the total number of the possible pairs of the parallel spins in the degenerate orbitals. When several electrons occupy a set of the degenerate orbital, the lowest energy state corresponds to the maximum possible extent of the single occupation of the orbital and parallel spin, Hund's rule. The loss of the exchange energy increases the stability. As the stability increases, the ionization becomes more difficult. There is no loss of the exchange energy at the d6 configuration. Mn plus has the 3d5 for configuration, and configuration of the sphere plus is 3d5. Therefore, the ionization enthalpy of the Mn plus is lower than the sphere plus. In the same way, Fe2 plus has the d6 configuration and Mn2 plus has the 3d5 configuration. Hence, the ionization enthalpy of the Fe2 plus is lower than the Mn2 plus. In other words, we can say that the third ionization enthalpy of the Fe is lower than that of the Mn. तो Mn प्लस का जो होता है वो कम होता है, 3d5 फॉर्मेशन होता है, और स्क्वायर प्लस का होता है d5. Fe2 प्लस का d6 होता है और Mn प्लस 2 का होता है 3d5. अब इसका आगे बात करते हैं कि the lowest common oxidation state of these metals is +2. To form the M2 plus ions form the gaseous atom. The sum of the first and the second ionization enthalpy required in addition to the enthalpy of the atomization. The dominant term is the second ionization enthalpy, which shows the unusually high value of the sphere and the cube, where the M plus ion have the d5 and the d10 configuration respectively. The value of the Zn is correspondingly low as the ionization causes the removal of the 1,4s electron, which results in the formation of the stable d10 configuration. This trend in the third ionization enthalpy is not complicated by the 4s orbital factor, and so the greater difficulty of removing an electron from the d5 Mn2 plus and the d10 Zn2 plus ion. In general, the third ionization enthalpy are quite high. Also, the high value for the third ionization enthalpy of the copper, nickel, zinc indicate why it is difficult to obtain oxidation state greater than the 2 for these elements. Although ionization enthalpy gives some guidance concerning the relative stability of the oxidation state, this problem is very complex and not amenable to ready generalization. अब बात करते हैं oxidation state की. तो one of the notable feature of a transition element is the great variety of the oxidation state they may show in their compound. Table 1.3 lists the common oxidation state of the first two transition element. तो scandium खाली +3 शो करता है, टाइटेनियम +2 +3 और +4 और प्लस मोस्ट कॉमन जो होता है वो बोल्ड में दिए हुए हैं. तो टाइटेनियम का मोस्ट कॉमन +4 है, वेनेडियम +2 +3 +4 +5, लेकिन इसका मोस्ट कॉमन +5 है. क्रोमियम +2 +3 +4 +5 +6, लेकिन इसका मोस्ट कॉमन +3 और +6 है. 3 और 6. Mn +2 +3 2 3 4 5 6 7 और 2 और 7 इसका है जो मोस्ट कॉमन है. फिर आयरन है जो 2 3 4 और 6 और 2 3 इसका मोस्ट कॉमन है. कोबाल्ट भी 2 3 4, लेकिन 2 3 भी इसका भी मोस्ट कॉमन है. निकल का 2 3 4 और 2 इसका मोस्ट कॉमन है. कॉपर का 1 और 2, लेकिन 2 इसका ज़्यादा मोस्ट कॉमन है. फिर जिंक का है जो 2 शो करता है खाली और 2 ही इसका मोस्ट कॉमन है. तो लार्जेस्ट नंबर ऑफ ऑक्सीडेशन स्टेट है जो Mn शो करता है, क्योंकि मोर नंबर ऑफ द अनपेयर्ड इलेक्ट्रॉन्स है जो इसके पास है. तो आगे फिर आता है कि द एलिमेंट्स विच गिव द ग्रेटेस्ट नंबर ऑफ द ऑक्सीडेशन स्टेट ऑकर इन or near the middle of the fridge. Manganese, for example, gives all oxidation state from +2 to +7. The lesser number of the oxidation state at the extreme ends stem from the either too few electrons to lose or to share scandium titanium, or too many electrons d electron, hence fewer orbitals available in which to share the electrons with the other for high valence of the copper and zinc. Thus early in the series scandium 2 is virtually unknown and titanium 4 is more stable than a titanium 3 or titanium 2. At the other end, the only oxidation state of the zinc is +2, no d electrons are involved. The maximum oxidation state of the renewable stability correspond in value to the sum of the F and D electrons up to the manganese Ti4O2 or B5O2 plus Cr6O42 minus Mn7O4 minus, followed by a rather abrupt increase in the stability of the higher oxidation state, so that a typical species to follow are the Fe2 or 3, कोबाल्ट 2 और 3, निकेल का 2 वाला ज़्यादा स्टेबल था, कॉपर का 1 और 2 और जिंक का खाली 2. The variability of the oxidation state is a characteristic of the transition element arise out of the incomplete filling of the d orbital in such a way that the oxidation state differ from each other by unity. Example, V2, V3, V4, V5. This is contrast with the variability of the oxidation state of the non-transition element, where the oxidation state normally differ by unit of the 2. An interesting feature in the variability of the oxidation state of the D block element is notified among the group 4 to group 10. Although in the P block, the lower oxidation states are favored by the heavier member due to the inert pair effect. The opposite is true in the group of the D block. For example, in the group 6, MO6 and the W6 are found to be more stable than the Cr6. Thus, the Cr6 is in the form of the dichromate is the acidic medium, is a strong oxidizing agent, whereas the MoO3 and the WO3 are not. फिर आता है लो ऑक्सीडेशन स्टेट. तो लो ऑक्सीडेशन स्टेट आर फाउंड व्हेन a complex compound has ligands capable of the pi acceptor character in addition to the sigma bonding. For example, in the NiCO4 and the FeCO5, the oxidation state of the nickel and the iron is 0. फिर आता है for example कि name a transition element which does not use the variable oxidation state. तो scandium Z=21 does not use the variable oxidation state. Which of the 3D series of the transition metal exhibit the largest number of the oxidation state and why? Mn, क्योंकि उसका सबसे ज़्यादा variable oxidation state है. फिर आता है trends in the M2 plus M of standard electrode potential. तो table 4.4 contains the thermochemical parameters related to the transformations of the solid metal atoms to the M2 plus ion in solution and their standard electrode potential. The observed value of the E and those calculated using the data 4.4 are compared in the figure 4.4. The unique behavior of the fuse having a positive electrode accounts for its inability to liberate the H2 from the acid. Only oxidizing acid, nitric acid, and the hot concentrated sulfuric acid react with the fuse, the acid bearing the reduced. The high energy to transform the fuse to Fu2 plus is not balanced by hydration enthalpy. The general trend towards the less negative electrode values across the series is related to the general increase in the sum of the first and the second ionization enthalpy. It is interesting to note that the value of the standard electrode for the Mn, nickel and zinc are more negative than expected from the trend. अब यहाँ पर एक टेबल दिखाया हुआ है. तो 3D सीरीज में सिर्फ कॉपर का ही पॉजिटिव एफआरपी होता है. कॉपर कैन नॉट लिबरेट द H2 फ्रॉम द एसिड से. तो ऑब्जर्वेड वैल्यूज यहाँ पर दिखाया हुआ है. ऑब्जर्वेड एंड द कैलकुलेटेड वैल्यू फॉर द स्टैंडर्ड इलेक्ट्रोड पोटेंशियल M2 plus M फॉर द एलिमेंट्स टाइटेनियम टू द जिंक. तो यहाँ पर दिखाया हुआ है अलग अलग का दिखाया हुआ है ऑब्जर्वेड वैल्यूज और कैलकुलेटेड वैल्यूज. तो टाइटेनियम, वैनेडियम, क्रोमियम, मैग्नीज, Fe, कोबाल्ट, निकेल, कॉपर और जिंक का दिखाया हुआ है. इस तरह से यहाँ पर दिखाया हुआ है ये. तो मैग्नीज का ये हो गया और निकल का यहाँ पर ये हो गया और ये हो गया जिंक का. अगला है solve example कि why is Cr2 plus reducing and Mn3 plus oxidizing when both have the default configuration. तो Cr plus is reducing, Cr2 plus is reducing as its configuration change from D4 to D3 in the latter having a half state T2G level. On the other hand, the change from the Mn3 plus to Mn2 plus result in the half state D5 configuration which has extra stability. फिर आता है the electrode M2 plus M value for the copper is positive plus 0.34. What is the possible reason for this? Hint, consider its high heat of atomization and the low hydration enthalpy. इसके बाद फिर आता है थर्मोकेमिकल डेटा किलो जूल पर मोल फॉर द फर्स्ट टू ट्रांजिशन एलिमेंट्स एंड द स्टैंडर्ड इलेक्ट्रोड पोटेंशियल फॉर द रिडक्शंस ऑफ द M2 to M. और यहाँ पर दिया हुआ है मिनिमम जो होता है ये 515 है और मैक्सिमम जो है 515 है और मिनिमम जो है 130 है निकल कॉपर जिंक के लिए. ओनली पॉजिटिव जो होता है वो कॉपर का ही होता है. उसके बाद ये डेटा है जो कुछ प्रकार से है. फिर इसके बाद नेक्स्ट है The stability of half-filled D cell in the Mn2 plus and the completely filled D10 configuration in the Zn2 plus are related to the electrode values, where the electrode for the nickel is related to the highest negative hit of the hydration. फिर आता है trends in the M3 plus M2 plus of standard electrode potential. तो an examinations of the electrode M3 plus M2 plus values show that the varying trends, the low value of the scandium reflects the stability of the Fe3 plus, which has a noble gas configuration. The highest value of the Zn is due to the removal of an electron from the standard D10 configuration of the Zn2 plus. The comparative high value of the Mn show that Mn2 plus D5 is particularly stable, whereas comparatively low value of the Fe show the extra stability of the Fe3 plus D5. The comparatively low value of the V vanadium is related to the stability of the V2 plus half-filled T2G level. फिर आता है ट्रेंड्स इन द स्टेबिलिटी ऑफ द हायर ऑक्सीडेशन स्टेट. तो टेबल 4.5 शो दैट द स्टेबल हाइलाइट्स ऑफ द 3D free of the transition metal. The highest oxidation numbers are achieved in the Ti export tetrahalides BF5 and the CrF6. The +1 of state for the Mn is not represented in the simple halide, but MnO3F is known, and beyond Mn no metal has a trihalide except FeX3 and the COF3. The ability of the fullerene to stabilize the highest oxidation state is due to either high lattice energy, as in the case of the COF3, or high bond enthalpy terms for the high air covalent compounds, example BF5 and the CrF6. Although B plus 5 is represented only by the BF5, the other halides, however, undergo the hydrolysis to give the oxo halides BOX3. Another feature of the fluoride is the instability in the low oxidation state BX2, hexavalproline, bromine और iodine, और इसको फर्फन रीजन में जो पूछ सकता है. तो CrF6 का है जो हाईएस्ट है, और इसमें आता है फार्मूलाज ऑफ द हाइलाइट्स इन द 3D मेटल्स में. तो CrF6 है जो हाईएस्ट है. तो इस प्रकार से है जो टेबल बना के है जो यहाँ पर इसको दिए हुए है, इसको देख सकते हैं टेबल को. स्टेबिलिटी इन द एक्वस सॉल्यूशन की बात करें तो Cu प्लस का कम होता है Cu+2 से एक्वस में. अब इसके आगे फिर है कि and the same apply to the CuX. On the other hand, all the Cu2 halides are known except for the iodide. In this case Cu2 plus oxidize I minus to the I2, तो Cu2 plus I minus को Cu2 I2 plus I2 में कन्वर्ट कर देता है. However, many copper 1 compounds are unstable in the aqueous solution and undergo the disproportionation. तो Cu plus जो है Cu2 plus में और Cu में disproportionate हो जाता है. The stability of the Cu2 plus rather than the Cu plus is due to the much more negative hit of hydrogen of the Cu2 plus aqueous than the Cu plus, which more than compensate for the second ionization enthalpy of the Cu. और इसको है जो AR में पूछ सकता है फर्फन रीजन बनाकर. The ability of the oxygen to stabilize the highest oxidation state is demonstrated in the oxide. The highest oxidation state in the oxide coincides with the group number and is attained in the Fe2O3 to the Mn2O7. Beyond group 7, no higher oxides of the Fe above the Fe2O3 are known. Therefore, all the ferrites 6 Fe4 FeO4 2- are formed in the alkaline media, but they are readily decomposed to Fe2O3 and the O2. Besides the oxide, oxocations stabilize the B5 as the BO2 plus B6 B4 and the BO2 plus on the Ti4 and the TiO2 plus. The ability of the oxygen to stabilize the high oxidation state exceeds that of the fullerene. Thus, the highest Mn fluoride is the MnF4, where the highest oxide is the Mn2O7. The ability of the oxygen to form the multiple bonds to a metal explains its superiority. In the covalent oxide, the Mn2O7, each Mn is tetrahedrally surrounded by the O, including the Mn bridge. The tetrahedral MO4N- ions are known as the B4, Cr6, Mn5, Mn6 and the Mn7. इसके बाद फिर यहाँ पर दिया ऑक्साइड्स ऑफ द 3D मेटल्स दिए हुए. तो ये हो गया मिक्सड ऑक्साइड्स. यहाँ पर हो जाता है ऑक्साइड्स ऑफ द 3D मेटल्स. तो Fe2O3 खाली यहाँ पर है, यहाँ पर TiO2, Ti2O3 और TiO है. फिर V2O5, V2O4, V2O3, VO है. CrO3, CrO2, Cr2O3 और CrO है. फिर Mn2O7, MnO2, Mn2O3, Mn3O4, MnO है. Fe2O3, Fe3O4, FeO है. CO3O4, CO है. NiO है, CO और Q2O, और इधर फिर आता है ZnO है. इसके बाद फिर आता है कि why would you account for the increasing oxidizing power in the fridge VO2 plus Cr2O7 MnO4 This is due to the increasing stability of the lower species to which they are reduced. Stability Mn2 plus 2, Cr plus 3 और V plus 4 इस प्रकार से आता है stability. फिर इंटेक्स क्वेश्चन है कि how would you account for the irregular variations of the ionization enthalpy first and the second in the first three of the transition elements. अब बात करते हैं आगे केमिकल रिएक्टिविटी एंड द इलेक्ट्रोड वैल्यूज की. तो ट्रांजिशन मेटल्स आर कहता है कि ट्रांजिशन मेटल्स आर वेरी badly in their chemical reactivity. Many of them are sufficiently electropositive to dissolve in the mineral acids, although a few are noble, that is, they are unaffected by the single acid. The metals of the first three, with the exceptions of the copper, are relatively more reactive and are oxidized by the 1 molar H+, though the actual rate at which these metal reacts with the oxidizing agent like the hydrogen ion H plus is sometimes slow. For example, titanium and vanadium in practice are perfect to dilute non-oxidizing acid at room temperature. The electrode values for the M2 plus M indicate a decreasing tendency to form a divalent cation across the series. This general trend towards the less negative electrode value is related to the increase in the sum of the first and the second ionization enthalpy. It is interesting to note that the electrode values for the Mn, nickel and the zinc are more negative than expected from the general trend, whereas the stability of the half-filled D subfield D5 in the Mn2 plus and completely filled D cell D10 in the zinc are related to the electrode values. For nickel, value is related to the highest negative enthalpy of the hydration. And the examination of the electrode value for the redox couple M3 plus M2 plus, so that the M3 plus couple and the CO3 ions are the strongest oxidizing agent in the aqueous solution. The ions Ti2 plus V2 plus and the Cr2 plus are strong reducing agent and will liberate the hydrogen from a dilute acid. So 2Cr2 plus 2H plus there is 2Cr3 plus H2. इसके बाद फिर आता है कि for the first two transition metals the electrode values are दिए हुए इस प्रकार से. एक्सप्लेन द इरेगुलरिटी इन द एबव वैल्यू. जैसे वनेडियम का -1.18, ठीक है, वनेडियम का -1.18 है, क्रोमियम का -0.91, मैग्नीज का -1.18, Fe का -0.44, कोबाल्ट का -0.28, निकल का -0.25 और कॉपर का +0.34. तो द इलेक्ट्रोड M2 plus M values are not regular, which can be explained from the irregular variation in the ionization enthalpy delta H1 plus delta H2 and also the sublimation enthalpy which are relatively much less for the manganese and the vanadium. अब ये वाला जो है सॉल्वर एग्जाम्पल 24 में ही पूछ दिया था. तो why the electrode value for the Mn3 plus Mn2 plus couple much more positive than that for the Cr3 plus Cr2 plus or the Fe3 plus Fe2 plus couple. Explain. So much larger third ionization energy for the Mn, where the required change is D5 to D4 is mainly responsible for this change. This also explains why the +3 state of the Mn is much more of the little importance. फिर आता है इंटेक्स क्वेश्चन है कि why is the highest oxidation state of a metal exhibited in the oxide or fluoride only, or which is the strong reducing agent Cr+2 or Fe+2 and why. अब आगे बात करते हैं मैग्नेटिक प्रॉपर्टीज की. तो when a magnetic field is applied to the substance, many two types of the magnetic behavior are observed: diamagnetism and paramagnetism. Diamagnetic substances are repelled by the applied field, where the paramagnetic substances are attracted. Substances which are attracted very strongly are said to be ferromagnetic. In fact, ferromagnetism is an extreme form of the paramagnetism. Many of the transition metals are paramagnetic. Paramagnetism arises from the presence of the unpaired electrons, each such electrons having a magnetic moment associated with the spin angular momentum and orbital angular momentum. For the compounds of the first stage of the transition metal, the contribution of the orbital angular momentum is effectively constant and hence is of no significance. For this, the magnetic moment is determined by the number of the unpaired electron and is calculated by using the spin-only formula. तो म्यू इक्वल टू होता है √n इंटू n प्लस 2, और ये 24 में इसको ही पूछा था. Where n is the number of the unpaired electron and mu is the magnetic moment in the Bohr magneton. A single unpaired electron has a magnetic moment of 1.73 Bohr magneton. The magnetic moment increases with the increasing number of the unpaired electrons. Thus, the observed magnetic moment gives a useful indication about the number of the unpaired electrons present in the atom, molecule, or the ion. The magnetic moment calculated from the spin-only formula and those derived experimentally for the some ions of the first row transition elements are given in table 7.4. The experimental data are mainly for the hydrated ions in the solution or in the solid state. पर यहाँ पर दिखाया हुआ है, कुछ डेटा दिखाया हुआ है. इसके बाद फिर आता है एग्जाम्पल 4.8 सॉल्यूशन. तो कैलकुलेट द मैग्नेटिक मोमेंट ऑफ ए डाइवेलेंट आयन इन एक्वस सॉल्यूशन इफ इट एटॉमिक नंबर इज 25. With the atomic number 25, the divalent ion in the aqueous solution will have d5 configuration with 5 unpaired electron. The magnetic moment mu will be mu equal to 5.92 यानी 5 point something इस प्रकार से आता है. कैलकुलेट द स्पिन only magnetic moment m2 plus ion z/27. फिर आता है फॉर्मेशन ऑफ द कलर्ड आयंस. So when an electron forms a lower energy d orbital is excited to a high energy d orbital, the energy of the excitation corresponds to the frequency of the light absorbed. The frequency generally lies in the visual region. The color absorbed corresponds to the complementary color of the light absorbed. The frequency of the light absorbed is determined by the nature of the ligand. In aqueous solution where water molecules are the ligands, the colors of the ions observed are listed in the figure 4.8. A few colored solutions of the d block elements are listed in the figure 4.5. The colors of the sum of the first two transition metals in the aqueous solution from the left to the right, B plus 4, B plus 3, Mn plus 2, Fe plus 3, CO plus 2, Ni plus 2 और CO plus 2 है जो दिखाया हुआ है। तो अब कलर का बात करें तो Sc3 प्लस और Ti4 प्लस कलरलेस होते हैं। उसी तरह से Zn प्लस 2 है जो कलरलेस होता है। बाकी सब कलर है, जैसे Ti3 प्लस जो होता है ये पर्पल होता है, B प्लस 4 ब्लू होता है, B3 प्लस ग्रीन होता है, B प्लस 2 वायलेट होता है, Cr3 प्लस वायलेट हो जाएगा, Mn3 प्लस वायलेट होगा, Cr2 प्लस ब्लू होगा, Mn2 प्लस पिंक होगा, Fe3 प्लस येलो होगा, Fe2 प्लस ग्रीन होगा, CO3 प्लस और CO2 प्लस ब्लू पिंक होगा, Ni2 प्लस ग्रीन होगा और CO2 प्लस होता है ब्लू। तो कलर ऑफ द सम ऑफ द फर्स्ट रो एक्वेटेड ट्रांजिशन मेटल आयंस का है जो दिए हुए। अब आता है फॉर्मेशंस ऑफ द कॉम्प्लेक्स कंपाउंड। तो complex compounds are those in which the metal ions binds a number of the anions for the neutral molecule giving complex species with characteristic property. For example are the Fe6 3 minus, Fe6 4 minus, UNH3K4 2 plus and the P2Cl4 2 minus. The chemistry of the complex compound is dealt in the figure in the detail in the unit 5. The transition metals form a large number of the complex compound. This is due to the comparatively smaller size of the metal atom, their high ionic charge and the ability of the d orbitals for the bond formation. Rather catalytic property. So the transition metals and their compounds are known for the catalytic activity. The activity ascribed to their ability to adopt multiple oxidation state and to form the complex phase. Vanadium oxide in contact process, finely divided iron in the Haber process, and the nickel in the catalytic hydrogenation are some of the example. Catalyst at a solid surface involves the formation of the bonds between the reactant molecule and the atoms of the surface of the catalyst. First two transition metals utilize 3D and the 4s electron for bonding. These are the effect of increasing the concentrations of the reactant at catalyst surface and also weakening of the bonds in the reacting molecule, the reactivation energy lowering. Also because the transition metals can change the oxidation state, they become more effective as the catalyst. For example, iron 3 catalyzes the reaction between the iodide and the persulfate ion. तो I minus plus F2O8 2 minus I2 plus 2SO4 2 minus देता है। An explanation of this catalytic action can be given as Fe3 plus plus 2I minus, तो उसको I2 में कन्वर्ट कर देगा, खुद Fe2 प्लस में कन्वर्ट हो जाएगा, Fe2 प्लस प्लस F2O2 माइनस तो Fe3 प्लस में कन्वर्ट हो जाएगा और FO4 2 माइनस से जो बन जाता है। फिर आता है फॉर्मेशन ऑफ द इंटरस्टिशियल कंपाउंड। तो इंटरस्टिशियल कंपाउंड आर दो विच आर फॉर्मेड व्हेन अ स्मॉल अमाउंट ऑफ स्मॉल एटम्स लाइक द hydrogen, carbon or nitrogen are trapped inside the crystal lattice of the metals. They are usually non-osteosymmetric and are directly typically ionic and they are non-osteosymmetric and neither typically ionic nor covalent. For example, TiC, Mn4, N, Fe3H, BH 0.56 and TiH 1.7 etc. The formulae quoted do not of course correspond to any normal oxidation state of the metal because of the nature of their composition. These compounds are referred to as the interstitial compound. The principal physical and the chemical characteristics of these compounds are as follow. They have high melting point, higher than those of the pure metals. They are very hard. Some bodies approach diamond in the hardness. They retain the metallic conductivity. They are chemically inert. इसके बाद फिर आता है alloy formation. तो an alloy is a blend of the metal. An alloy is a blend of the metals prepared by mixing the components. Alloy may be homogeneous solid solution in which the atoms of one metal are distributed randomly along the atoms of the other. Such alloy are formed by the atoms with the metallic radii that are within the 15% of each other. Because of the similar radii and the other characteristic of the transition metal, alloys are directly formed by these metals. The alloys so formed are hard and have often high melting point. The best known are the ferrous alloys, chromium, vanadium, tungsten, molybdenum, and the manganese are used for the production of a variety of the steels and the stainless steel. Alloys of the transition metal with the non-transition metal such as the brass, copper, and zinc, bronze, copper, tin are also considerable industrial importance. फिर एक फॉर एग्जाम्पल है कि वाट ई मींट बाय द डिस्प्रोपोर्शन ऑफ एन ऑक्सीडेशन स्टेट, गिव एन एग्जाम्पल. तो व्हेन ए पार्टिकुलर ऑक्सीडेशन स्टेट बिकम्स लेस स्टेबल ड्यू टू द less stable related to the other oxidation state, one lower, one higher, it is said to undergo the disproportionation. For example, manganese 6 becomes unstable due to the manganese 7 and manganese 4 in the acidic medium. Mn6O4 2 minus plus 4H plus Mn7O4 minus plus Mn 4O2 प्लस 2H2O है जो बन जाता है। फिर आता है एक्सप्लेन वाई Cu प्लस आयन इज नॉट स्टेबल इन द एक्वस सॉल्यूशन। अब इसके बाद फिर आता है सम इंपॉर्टेंट कंपाउंड्स ऑफ द ट्रांजिशन एलिमेंट ऑक्साइड्स एंड ऑक्सोनाइंस ऑफ द मेटल। तो ये है जो स्टेटमेंट 23 का पूछा हुआ है ऐसे। द ऑक्साइड्स आर जनरली फॉर्मेड बाय द रिएक्शंस ऑफ द मेटल्स विद ऑक्सीजन एट द रूम टेम्परेचर। ऑल द मेटल्स एक्सेप्ट स्कैंडियम फॉर्म्ड MO oxides which are ionic. The highest oxidation state in the oxides coincide with the group number and the attained in the Fe2O3 to Mn2O7. Beyond group 7, no higher oxides of the iron above Fe2O3 are known. Besides these oxides, the oxocations stabilize the B5 at the BO2 plus, B4 at the BO2 plus, and the TI4 at the TiO2 plus. As the oxidation of number of a metal increases, ionic character decreases. In the case of the Mn2O7 is equivalent green hole. Even CrO3 and the Br2O5 have the low melting point. In these higher oxides, the acidic character is predominant. Thus, Mn2O7 gives the HMnO4 and the CrO3 gives the H2CrO4 and the H2Cr2O7. Br O5 is however amphoteric, though mainly acidic, and it gives the BO4 3- as well as the BO2 plus salt. In vanadium, there is a gradual change from the basic B2O3 to less basic B2O4 and to the amphoteric B2O5. B2O4 dissolves in the acids to give the BO2 plus salt. Similarly, B2O5 reacts with alkalis as well as the acids to give the BO4 3- and the BO4 plus respectively. The Bell characteristic of the CRO is basic, but the Cr2O3 is the amphoteric. Next है potassium dichromate K2Cr2O7. तो potassium dichromate is a very important chemical used in the leather industry and as an oxidant for the preparation of many adjuvant compounds. Dichromates are generally prepared from the chromate, which in turn are obtained by the fusion of the chromate or FeCr2O4 with the sodium or potassium carbonate in the free access of the air. The reaction with the sodium carbonate occurs as follows: FeCr2O4 plus Na2CO3 plus O2 देगा Na2CrO4 plus Fe2O3 plus CO2. The yellow solutions of the sodium chromate is filtered and acidified with the sulfuric acid to give a solution from which the orange sodium dichromate Na2Cr2O7.2H2O can be crystallized. अब इसके आगे बात करते हैं सोडियम डाइक्रोमेट is more soluble than the potassium dichromate. The latter is therefore prepared by treating the solution of the sodium dichromate with the potassium chloride. The Na2Cr2O7 plus KCl K2Cr2O7 plus NaCl देगा. Orange crystals of the potassium dichromate crystallize or dichromates and the dichromates are interconvertible in the aqueous solution depending upon the pH of the solution. The oxidation state of the chromium in the chromate and dichromate are the same. तो CrO4 2- plus 2H plus Cr2O7 2- में कन्वर्ट हो जाता है प्लस H2O और Cr2O7 2- plus 2HO- तो CrO4 2- plus H2O में है जो कन्वर्ट हो जाता है। यहाँ पर ये दिए हुए क्रोमेट आयन का स्ट्रक्चर CrO4 2- और यहाँ पर डाइक्रोमेट Cr2O7 2- का जो दिया हुआ है इसमें 179 पिकोमीटर होता है 126 डिग्री और 153 पिकोमीटर होता है। Next है the structure of the chromate ion CrO4 2- and the dichromate ion Cr2O7 2- are shown below. The chromate ion is tetrahedral where the dichromate ion consists of the two tetrahedra sharing one corner CrO-Cr bond angle of the 126 degree. Sodium and potassium dichromates are a strong oxidizing agent. The sodium salt has the greater solubility in the water and extensively used as a strong oxidizing agent in organic chemistry. Potassium dichromate is used as a primary standard in the volumetric analysis in the acidic solution. Its oxidizing action can be represented as follows: Cr2O7 2- plus 14 plus 6 electron, Cr3 plus 1H2O. Thus, the acidified potassium dichromate will oxidize the iodide to the iodine, sulfide to the sulfur, tin 2 to the tin 4, and iron 2 salt to the iron 3. The half reaction are noted as 6I- to 3I2 plus 6 electron or 3H2O 6H plus 3S plus 6 electron, फिर Fn2 plus Fn4 4 plus और Fe2 plus Fe3 plus में कन्वर्ट हो जाता है. The full ionic equation may be obtained by adding the half reaction for the potassium dichromate to the half reactions of the for the reducing agent. Cr2O7 2- plus 6 14H plus 6 Fe2 plus Cr3 plus 6 Fe3 plus 7H2O. फिर आता है पोटेशियम परमैंगनेट KMnO4. तो पोटेशियम परमैंगनेट is prepared by fusion of the MnO2 with an alkali metal hydroxide and an oxidizing agent like the KNO3. This produces a dark green K2MnO4 which disproportionate in a neutral or acidic solution to give the permanganate. तो MnO2 plus 4KOH plus O2 तो K2MnO4 plus 2H2O और MnO4 2- plus 4H plus तो MnO4- plus MnO2 plus H2O देता है. Commercially, it is prepared by the alkaline oxidative fusion of the MnO2 followed by the electrolytic oxidation of the magnet 6. फिर आता है MnO2 fused with the QH oxidized with the air or the KNO3 MnO4 2 minus magnet ion. फिर MnO4 2 minus magnet फिर इलेक्ट्रोलाइटिक ऑक्सीडेशन इन अल्कलाइन सोल्यूशन करेंगे तो MnO4 माइनस यानी परमानेंट आयन है जो बन जाएगा. अब इसका आगे होता है कि इन द लेबोरेटरी ए मैग्नीज 2 iron faulty oxidized by the peroxidized sulfate to the permanganate Mn2 plus F2O8 2 minus plus 8H2O तो MnO4 minus plus 10FO4 2 minus plus 15H plus में कन्वर्ट होगा. Potassium permanganate forms the dark purple almost black crystal which are isostructural with those of the KClO4. The fault is not very soluble in the water 6.4 gram per 100 gram water at 293 Kelvin but when heated it decomposes at 513 Kelvin. KMnO4 plus K देगा K2MnO4 plus MnO2 plus O2. It has two physical property of the considerable interest. Its intense color and its diamagnetism along with the temperature dependent big paramagnetism. This can be explained by the use of the molecular orbital theory which is beyond the present scope. यहाँ पर दिया हुआ टेट्राहेड्रल मैग्नेट आयरन ग्रीन और टेट्राहेड्रल पर मैग्नेट आयरन पर्पल है जो दिखाए हुए. तो टेट्राहेड्रल मैग्नेट जो होता है वो ग्रीन होता है, ग्रीन में दिखा भी दिया है. और टेट्राहेड्रल पर मैग्नेट जो होता है वो होता है पर्पल, तो ये पर्पल का दिखाया हुआ है. इसके बाद फिर आता है द मैग्नेट एंड द परमानेंट एंड फॉर टेट्राहेड्रल द पाई बॉन्डिंग टेक प्लेस बाय द ओवरलैप ऑफ द p orbitals of the oxygen with the d orbitals of the manganese. The green magnet is paramagnetic because of the one unpaired electron, but the paramagnet is diamagnetic due to the absence of the unpaired electron. A certified paramagnet solution oxidize the oxides to carbon dioxide, iron 2 to the iron 3, nitrates to the nitrates, and iodides to the free iodine. The half reactions of the reactants are जैसे ऑक्जेलेट्स है तो उसको 10CO2 में कन्वर्ट करेगा. Fe2 प्लस को Fe3 प्लस में, NO2 को NO3 माइनस में और I माइनस को I2 में कन्वर्ट करेगा. द फुल रिएक्शन कैन बी रिटन बाय एडिंग द हाफ रिएक्शन फॉर द KMnO4 टू द हाफ रिएक्शन ऑफ द रिड्यूसिंग एजेंट बैलेंसिंग वेयर नेसेसरी. इफ वी डिपेंड द reactions of the permanganate to the magnet manganese dioxide and manganese fault by the half reaction तो MnO4 minus plus electron MnO4 2 minus और MnO4 minus plus 4H plus 3 electron तो MnO2 plus 2H2 हो जाता है. MnO4 minus plus 8 plus 5 electron तो Mn2 plus 4H2 हो जाता है. We can very well see that the hydrogen ion concentrations of the solution play an important part in influencing the reaction. Although many reactions can be understood by considering of the redox potential, kinetics of the reaction is also important factor. Permanganate at the hydrogen concentration H plus concentration 1 should oxide water, but in practice the reaction is extremely slow unless either manganese 2 ions are present or the temperature is raised. A few important oxidizing reactions of the KMnO4 are given below. In the acid solution, iodine is liberated from the potassium iodide 10I minus plus 2 MnO4 minus plus 15H plus Mn2 plus H2O plus 5I2 और Fe2 plus green is converted to the Fe3 plus यानी जो कि होता है येलो. तो Fe2 plus से है जो Fe3 plus में कन्वर्ट हो गया यानी ग्रीन से येलो में. ऑक्जेलेट आयन और ऑक्जेलिक एसिड ऑक्सीडाइड एट द 333 केल्विन और Fe2O4 2 माइनस को है जो CO2 में कन्वर्ट हो गया. MnO4 minus Mn2 plus में कन्वर्ट हो गया. हाइड्रोजन सल्फाइड इज ऑक्सीडाइड सल्फर बिंग प्रेसिपिटेटेड H2O जो H प्लस और F2 माइनस में और F2 माइनस प्लस MnO4 माइनस Mn2 प्लस F में कन्वर्ट हो जाता है. सल्फरस एसिड और द सल्फाइड इज ऑक्सीडाइड टू द सल्फेट और द सल्फ्यूरिक एसिड तो 5SO32 माइनस जो SO42 माइनस में कन्वर्ट हो जाता है. MnO4 माइनस जो Mn2 प्लस में कन्वर्ट हो गया. नाइट्राइट इज ऑक्सीडाइड टू द नाइट्रेट तो NO2 माइनस जो NO3 माइनस में कन्वर्ट हो गया. MnO4 माइनस जो Mn2 में कन्वर्ट हो गया. In neutral or the friendly alkaline solution, a notable reaction is the oxidation of the iodide to the iodate तो MnO4 minus plus H2 plus I minus MnO2 plus 2H plus IO3 minus में कन्वर्ट हो गया. Thiosulfate is oxidized almost quantitatively to the sulfate and manganese fault is oxidized to the MnO2. The presence of the zinc sulfate or the zinc oxide catalyzes the oxidation. MnO4 minus plus Mn2 plus 2H2O MnO2 plus 4H plus. Permanganate titration in the presence of the hydrochloric acid are unsatisfactory since the hydrochloric acid is oxidized to the chlorine. अब इसके बाद फिर आता है usage. तो besides which used in the analytical chemistry, potassium permanganate is used as a favorite oxidant in the preparative organic chemistry. It uses for the bleaching of the wool, cotton, silk, and other textile fibers, and for the decolorization of the wools are also dependent on its strong oxidizing power. अब आगे बात करते हैं द इनर ट्रांजिशन एलिमेंट्स F ब्लॉक की. So the F block consists of the two free lanthanode, the 14 elements following the lanthanum, and the actinodes, the 14 elements following the actinium. Because lanthanum clearly resembles the lanthanodes, it is usually included in any discussion of the lanthanode for which the general symbol Ln is often used. Similarly, a discussion of the actinodes includes the actinium besides the 14 element constituting the free. The lanthanode resemble the one another more closely than do the members of the ordinary transition elements in any free. They have only one stable oxidation state, and their chemistry provides an excellent opportunity to examine the effect of the small change in the phi and the nuclear charge along a fringe of the other by similar elements. The chemistry of the actinide is on the other hand much more complicated. The complication arises partially owing to the occurrence of the wide range of the oxidation state in these elements and partially because of their radioactivity creates special problems in their study. The two fringes will be considered separately here. फिर आता है the lanthanodes. तो the name symbols electronic configuration of the atomic of some of the atomic and some ionic states on the atomic and the ionic radii of the lanthanum and the lanthanodes for the general symbol Nn and Jude are given in table 4.9. फिर आता है electronic configuration. So it may be noted that atoms of these elements may have electronic configuration with the 6s2 common but with the variable occupancy of the 4f level. However, the electronic configuration of all the tripositive ions, the most stable oxidation state of all the lanthanodes are of the form 4fn n बराबर 1 to 14 with the increasing atomic number. फिर आता है atomic and the ionic phase. यहाँ पर atomic number दिए हुए और इधर दिए हुए है आयोनिक रेडियाई पिकोमीटर में. ट्रेंड्स इन द आयोनिक रेडियाई ऑफ द लैंथानोड्स ये दिखाया हुआ है. तो आयोनिक रेडियस का फाज है जो डिक्रीज करेगा. नेक्स्ट यहाँ पर आता है कि द ओवरऑल डिक्रीज इन द एटॉमिक एंड द आयोनिक रेडियाई फ्रॉम द लैंथानम टू द ल्यूटेटियम. द लैंथानोड कॉन्ट्रैक्शन इज यूनिक फीचर ऑफ द केमिस्ट्री ऑफ द लैंथानोड. इट हैज फार रीचिंग consequences in the chemistry of the third transition series of the elements. The decrease in atomic radii derived from the structure of the metals is not quite regular as regular in the M3 plus ion. This contraction is of the course similar to the observed in the ordinary transition series and is attributed to the same cause. The imperfect fielding of one electron by the another is in the same subshell. However, the fielding of the one 4f electron by the another is less than the d electron by the another with the increase in the nuclear charge along the series. There is fairly regular decrease in the phi with the increasing atomic number. The cumulative effect of the contractions of the lanthanode series known as the lanthanode contraction cause the radii of the members of the third ionization series to be very similar to those of the corresponding members of the second series. The almost identical radii of the Jedar, Ecofat and the hafnium 159 picometer, a consequence of the lanthanode contraction, accounts for their occurrence together in the nature and for the difficulty preferred in their separation. फिर आता oxidation state. तो in the lanthanodes La2 and the Ln3 compounds are the predominant species. However, occasionally +2 and the +4 oxidation state in the soluble or in the solid compounds are also obtained. This irregularity as in the ionization enthalpy arise mainly from the extra stability of the empty half-filled or the filled F cell. Thus, the formation of the Ce4 is favored by its noble gas configuration but is a strong oxidant independent to the common +3 state. The standard electrode value for the C4 plus C3 plus 1.14 which suggests that it can oxidize water. However, the reaction rate is very slow and hence C4 is a good analytical agent. PR, ND, TB and DI also with the +4 state but only in the oxide. MO2 plus U2 plus is formed by losing the 2 F electron and its F7 configuration account for the formation of this ion. However, U2 plus is a strong reducing agent changing to the common +3 state. Similarly, Bi2 plus which has the F14 configuration is a reductant. TB4 has the half-filled F orbitals and is an oxidant. The behavior of the samarium is very much like the europium exhibiting both +2 and the +3 oxidation state. The U2 plus is a strong reducing agent है, Bi2 plus strong reducing agent है और TB4 plus है जो strong ये है जो ऑक्सीडाइजिंग एजेंट में आता है. सी का +4 ऑक्सीडेशन स्टेट में नोबल गैस कन्फर्मेशन है जो होता है. तो F14 में Bi2 प्लस और Lu3 प्लस है यानी लालू और F0 में आता है La3 प्लस एंड द C+4 यानी कि लालू और सीबा. ये दोनों है जो कम्प्लीटली फिलेड है या कह सकते हैं कि स्टेबल है. इसके बाद फिर आता है इलेक्ट्रॉनिक कन्फिगरेशंस ऑफ द रेडियस ऑफ द लैंथानम एंड द लैंथानोड्स. तो सीरियम का देख सकते हैं 4f0 है, यूरोपियम का देख सकते हैं 4f7 है, 4f6 है और यहाँ पर एक देख सकते हैं टर्बियम का हाफ फ्लेड है 4f7 है. इटरबियम का है जो 4f14 है और इसका है जो ल्यूटेटियम का 4f14 है और कलरलेस होता है. तो लैंथानम, सीरियम, प्रेसियोडाइयम, नियोडाइनियम, प्रोमिथियम, फेमेरियम, यूरोपियम, गैडोलिनियम और टर्बियम। उसके बाद फिर आता है गैडोलिनियम का, देख सकते हैं एक बार, गैडोलिनियम का भी एक बार देख सकते हैं, ये होता है 7F4 5D1 6F2 7F और 4F7, इस प्रकार से आता है। फिर टर्बियम, डाइस्प्रोस्मियम, होल्मियम, अर्बियम, थूलियम, इटरबियम, लुटेटियम, इस प्रकार से जो आते हैं। तो फेमेरियम इज अ स्टील हार्ड, मेल्टिंग पॉइंट होता है 1623 केल्विन। अब इसमें है जनरल कैरेक्टरिस्टिक, तो ऑल द लैंथेनोइड्स आर very bright soft metals and tarnish rapidly in the air. The hardness increase with increased atomic number. Samarium being still hard. The melting point range between the 1000 to 1200 Kelvin, but samarium melt at 1200 Kelvin. They have typical melting metallic structure and are good conductors of the heat and electricity. Density, another property, change smoothly except for the U and the BB, and occasionally for the SM and the TM. Many trivalent node ions are colored both in the solid state and in the aqueous solution. Color of these ions may be attributed to the presence of the F electron. Neither La3 plus and the Lu3 plus can show any color, but the rest do so. However, absorption bands are narrow, probably because of the excitations of the within the F level. The node ions other than the F0 type, La3 plus and the C4 plus and the F14 type, Bib2 plus and the Lu3 plus are all paramagnetic. अब यहाँ पर से जो क्वेश्चन ना किया जो दे दिया था, जिसमें Cu+4 और Bib2 प्लस जो था कलरलेस था, ऐसे है जो दे दिया था ऑप्शन करके, एक यहाँ को उठा लिया, एक यहाँ से उठा लिया था। द फर्स्ट आयोनाइजेशन एंथैल्पी फॉर द लैंथेनोइड्स अराउंड 600 किलोजूल पर मोल एंड द सेकंड around 1200 kilojoule per mole, comparable with those of the calcium. A detailed discussion of the variations of the third ionization enthalpy indicate that the exchange enthalpy configuration, as in the 3D orbital of the first transition series, appear to impart a certain degree of the stability to the empty, half-filled and comparatively filled orbitals of F level. This is indicated from the abnormally low value of the third ionization enthalpy of the lanthanum, gadolinium and lutetium. In the chemical behavior in general, the earlier members of the series are quite reactive similar to the calcium, but the increasing atomic number they behave more like the aluminum. Values of the standard electrode potential for the half reaction Ln3 plus 3 इलेक्ट्रॉन Ln हो जाता है सॉलिड। और ये वाला जो था ये 22 में पूछा था। अब एक यहाँ पर है कि Ln3C, Ln2C3 और Ln3 एग्जिस्ट करता है, लेकिन Ln2C है जो एग्जिस्ट नहीं करता है, सही है। इसके बाद फिर यहाँ पर दिया हुआ है केमिकल रिएक्शंस ऑफ द लैंथेनोइड। तो अगर Ln+3 एसिड विफाद करेगा तो हाइड्रोजन लिबरेट करेगा, विथ दी हैलोजन्स Lnx3 करेगा, विथ दी H2O LnOH3 प्लस H2 करेगा क्योंकि Ln3 प्लस कर रहा है, विथ दी कार्बन 2773 केल्विन पर Ln2 करेगा, और हीटेड विद द नाइट्रोजन तो Ln करेगा, हीटेड विद द सल्फर तो Ln2F3 करेगा, और बर्न इन द O2 तो Ln2O3 है जो कहता है, लेकिन Ln2C फॉर्म नहीं होता है। तो वैल्यूज फॉर द इलेक्ट्रोड फॉर द हाफ रिएक्शन आर इन द रेंज ऑफ द -2.2 to -2.4 except for the U for which the value is -2.0. This is of course a small variation. The metals combined with the hydrogen when gently heated in the gas. The carbide Ln3C, Ln2C3 and Ln2 are formed when the metals are heated with the carbon. They liberate the hydrogen from the dilute acid and burn in the halogen to form the halides. They form the oxides M2O3 and the hydroxides MOH3. The hydroxides are definite compounds, not just hydrated oxides. They are basically just like the alkaline earth metal and hydroxides. Their general reactions are depicted in the figure 4.7. फिर आता है कि the best single use of the lanthanoids is for the production of the alloy of steel for the plates and the pipes. A well-known alloy is the mixed metal, which consists of the lanthanoid metal 95% and the iron 5% and traces of the sulfur, carbon, calcium and the aluminum. A good deal of the mixed metal is used in the magnesium-based alloy to produce the bullet cells and the lighter flint. Mixed oxides of the lanthanoids are employed as a catalyst in the petroleum cracking. Some individual Ln oxides are used as a phosphorus in the television screen and the similar fluorescing surfaces. फिर आता है actinoids. तो the actinoids include the 14 elements from the thorium to the lawrencium. The name, symbols and the some property of these elements are given in table 4.10. फिर आता है थोरियम का दिया हुआ है 6d2 7f2, अमेरिकन का है 5f7 7f2, क्यूरियम का आता है 712, इसका भी आता है, क्यूरियम का भी 712 आता है। ऐसा है एक्टिनियम, थोरियम, प्रोटैक्टियम, यूरेनियम, नेपटूनियम, प्लूटोनियम, अमेरिकम, क्यूरियम, बर्केलियम, कैलिफोर्नियम, अनस्टीनियम, फर्मियम, मैंडेविलियम, नोवलियम और लॉरेंसियम। तो ये हो जाता है सम प्रॉपर्टी ऑफ द एक्टिनियम एंड द एक्टिनॉइड्स का हो जाता है। अब इसका आगे आता है कि द एक्टिव नॉट्स आर द रेडियो एक्टिव एलिमेंट्स एंड द अर्लियर मेंबर्स हैव द relatively long half-life. The latter ones have the half-life value ranging from the 88 to 3 minutes for the lawrencium Z-14. The latter members could be prepared only in the nanogram quantity. These facts render their study more difficult. All the active nodes are believed to have the electronic configuration of the 7f2 and variable occupancy of the 5f and the 6d subcell. The 14 electrons are formally added to the 5f, though not in the thorium Z-90, but from the Pa onwards, the M5f orbital are complete at the element X14. Their irregularities in the electronic configuration of the actinoid, like those in the lanthanoids, are related to the stability of the F0, F7, F14 occupancy of the 5f orbital. Thus, the configuration of the americium and the cm are the Rn5f7, 7f2, and Rn5f7, 6d1, and the 7f2. Although the 5f orbital resemble the 4f orbital in their angular part of the wave function, they are not as buried as the 4f orbital, and hence the 5f orbital can participate in the bonding to a far greater extent. और इसको एसोसिएशन रीजन बना के पूछा जा सकता है. फिर बात करते हैं आयोनिक फाजेज की. तो जनरल ट्रेंड इन द lanthanide observable in the actinide fibril. There is a gradual decrease in the size of the atoms of the M3 plus ion across the fridge. This may be referred to as the actinoid contraction. Like the lanthanoid contraction, the contraction is however greater from the element to the element in the fridge, resulting from the pore filling by the 5f orbital. फिर आता है oxidation of state. So there is a greater range in the oxidation of state, which is a part attributed to the fact that the 5f, 6d, and the 7f levels are comparable in energy. The non-oxidation state of the actinides are listed in table 4.11. The actinides show in general plus 3 oxidation state. The elements in the first half of the fridge frequently exhibit the higher oxidation state. For example, the maximum oxidation state increase from the plus 4 in the thorium to plus 5, plus 6, plus 7 respectively in the Pa, U, and the Np. Newspaper, ठीक है, but decrease in the sulfiding element. The actinoids resemble the lanthanoids when having more compounds in the plus 3 state than in the plus 4 state. However, the plus 3 and the plus 4 ions tend to hydrolyze because the distributions of the oxidation state among the actinoids is so uneven and so different from the former and later elements. It is unsatisfactory to review their chemistry in the terms of the oxidation state. नेक्स्ट है ऑक्सीडेशन स्टेट ऑफ द एक्टिनियम एंड द एक्टिनॉइड्स का दिए हुए. तो यहाँ पर आ गया थोरियम 4, Pa 5, U6, Np 7 और Pu है जो 7 आता है. नेक्स्ट फिर आता है जनरल कैरेक्टरिस्टिक एंड द कंपेरिजन ऑफ द लैंथानोड. मैन मेड में आता है Np, Ns और लॉरेंस Np 93 और लॉरेंसम 103 आता है. जनरल कैरेक्टरिस्टिक एंड द कंपेरिजन विद द लैंथानोड्स. उसके बाद फिर आता है कि द एक्टिव नोड्स मेटल्स आर ऑल सिल्वरी in the appearance but display variety of the structure. The structural variety is obtained due to the irregularity in the metallic radii, which are far greater than in the lanthanodes. The actinoids are highly reactive metals, especially when finely divided. The actions of the boiling water on them, for example, gives a mixture of the oxide and the hydride, and the combination with most non-metal take place at the moderate temperature. Hydrochloric acid attacks all metal, but most are slightly affected by the nitric acid owing to the formation of the protective oxide and layers. Alkalis have no action. The magnetic properties of the actinoids are much more complex than those of the lanthanoids, although the variation in the magnetic susceptibility of the actinoids with the number of the unpaired 5 electrons is roughly parallel to the corresponding results of the lanthanode. The latter have the higher values. इसके बाद फिर ये 23 में पूछा था कि it is evident from the behavior of the actinoids that the ionization enthalpy of the early actinoids do not accurately known but are lower than that of the early lanthanoids. This is required to enable sensitivity to be expected that when the 5f orbital are beginning to be occupied, they will penetrate less into the inner core of the electron. The 5f electron will therefore be more effectively from the nuclear charge than the 4f electron to the corresponding lanthanode. Because of the outer electrons are less firmly held, they are available for the bonding in the actinoids. A comparison of the actinoids with the lanthanode with respect to the different characteristics I discussed above reveals that behavior similar to that of the lanthanoids is not evident until the second half of the actinoid series. However, even the early actinoids resemble the lanthanoids in showing the close similarity with each other and a gradual variation in the property which do not entail change in the oxidation state. The lanthanode and the actinoid contraction have extended effects on the size and therefore the property of the elements succeeding them in their respective period. The lanthanode contraction is most important because the chemistry of the elements succeeding the actinoids are much less known at the present times. इसके बाद फिर आता है एक फॉरवर्ड एग्जाम्पल है कि नेम ए मेंबर ऑफ द लैंथेनॉइड सीरीज विच इज वेल नोन टू विद द प्लस पर ऑक्सीडेशन स्टेट तो सीरियम Z58 और एक्टिनॉइड कॉन्ट्रैक्शन इज greater from element to element than the lanthanide contraction Y. अब इसके बाद फिर आता है सम एप्लीकेशंस ऑफ द D एंड द F ब्लॉक. So iron and the steel are the most important construction material. Their production is based on the reductions of the iron oxide, the removal of the impurity, and the additions of the carbon and alloying metals such as the chromium, manganese, and nickel. Some compounds are manufactured for the special purpose such as the TiO for the pigment industry and the MnO2 for the use in the dry battery cell. The battery industry also requires the Zn and the NiCd. The elements of the group 11 are still body of being called the coinage metals, although Ag and the Au are restricted to the collection items, and the contemporary UK copper coins are copper coated steel. The silver UK coins are CuNi alloy. Many of the copper metals and their compounds are essential catalysts in the chemical industry. V2O5 catalyze the oxidation of the FO2 in the manufacture of the sulfuric acid. TiCl4 with the Lc3 forms the basis of the Ziegler catalyst used to manufacture the polythene. Iron catalysts are used in the Haber process for the production of the ammonia from the N2H2 mixture. Nickel catalysts enable the hydrogenations of the fat to proceed. In the Wacker process, the oxidations of the ethane to the ethanol is catalyzed by the PDCl2. ठीक है. Nickel complexes are used in the polymerizations of the alkynes and other organic compounds such as the benzene. The photographic industry relies on the specific light sensitive property of the AgBr. जर्मन सिल्वर में Cu Zn plus Ni होता है. अब इसका समरी देख लेते हैं. तो समरी में है कि द डी ब्लॉक कंसिस्टिंग ऑफ द ग्रुप 3 to 12 ऑक्युपाई द लार्ज मिडिल सेक्शंस ऑफ द पीरियोडिक टेबल. इन these elements the inner d block d orbitals are powerfully filled. The f orbital f block is placed outside at the bottom of the periodic table and in the elements of this block. For f and f5f are powerfully filled. Corresponding to the filling of the 3d, 4d and the 5d orbitals, their three series of the transition elements are well recognized. All the transition elements exhibit the typical metallic properties such as the high tensile strength, ductility, malleability, thermal and electrical conductivity, and the metallic character. Their melting and the boiling points are high, which are attributed to the involvement of the n-1d electron, resulting into the strong interatomic bonding. In many of these properties, the maxima occur at about the middle of each series, which indicate that one unpaired electron per d orbital is particularly favorable configuration for a strong interatomic interaction. Successive ionization enthalpy do not increase as steeply as in the main group elements with increasing atomic number. Hence, the loss of the variable number of the electrons from the n-1d orbital is not generally energetically favorable. The involvement of the n-1d electrons in the behavior of the transition elements imparts certain distinct characteristics to these elements. Thus, in addition to these oxidational state, they exhibit a paramagnetic behavior, catalytic property, and tendency for the formation of the colored ions, interstitial compounds, and the complexes. The transition metals vary widely in their chemical behavior. Many of them are sufficiently electropositive to dissolve in the mineral acids, although a few are noble of their fine stage. With the exceptions of the copper, all the metals are relatively reactive. The transition metals react with a number of the non-metals like the oxygen, nitrogen, sulfur, and halogen to form the binary compounds. The first two transition metal oxides are generally formed from the reaction of the metals with the oxygen at the high temperature. These oxides dissolve in the acids and the bases to form the oxalometallic salts. Potassium dichromate and the potassium permanganate are common examples. Potassium dichromate is prepared from the chromator by the fusion with alkali in the presence of the air and acidifying the extract. Pyrophite or MnO2 is used for the preparation of the potassium permanganate. Both the dichromate and the permanganate ions are a strong oxidizing agent. The two series of the inner transition elements, lanthanoids and actinioids, constitute the F block of the periodic table. With the successive filling of the inner orbital for F, there is a gradual decrease in the atomic and the ionic size of these elements metals along the series lanthanoid contraction. This has far-reaching consequences in the chemistry of the elements succeeding them. Lanthanum and all the lanthanoids are rather soft white metals. They react easily with the water to give solution giving the plus 3 ions. The principal oxidation state is plus 3, although plus 4 and the plus 2 oxidation state are exhibited by the sum. Occasionally, the chemistry of the actinides is more complex in view of our ability to exist in the different oxidation state. Furthermore, many of the actinides are radioactive, which make the study of the elements rather difficult. There are many useful applications of the D and the F block elements and their compounds, notable among them in the variety of the steel, catalyst complexes, organic synthesis, etc. आप कुछ क्वेश्चन है जैसे राइट डाउन द इलेक्ट्रॉनिक कन्फिगरेशन ऑफ द Cr3 प्लस Pm3 प्लस Cu प्लस Cu4 प्लस Co2 प्लस Lu2 प्लस and Mn2 प्लस and Th4 प्लस. Why are Mn2 plus compounds more stable than the Fe3 plus Fe2 plus towards the oxidation to their plus 3 state? Explain briefly how the +2 state becomes more and more stable in the first half of the first two transition element with increasing atomic number. To Bhatt extend to the electronic configuration defines the stability of the oxidation state in the first series of the transition element. Illustrate answer with the example. Bhatt may be the stable oxidation state of the transition element with the flying d electron configuration in the ground state of their atoms 3d3, 3d5, 3d6, 3d4. Name the oxo metal and ions of the first series of the transition metal in which the metal exhibits the oxidation state equal to the group number. What is the lanthanide contaction? What are the consequences of the lanthanide contaction? What are the characteristics of the transition elements and why are they called the transition elements? Which of the d block elements may not be regarded as a transition element? In what way the electronic configuration of the transition element different from of the non-transition element? What are the different oxidation state exhibited by the lanthanodes? Explain giving region, transition metals and many of their compounds for the paramagnetic behavior. The enthalpies of the atomization of the transition metals are high. The transition metals are generally form colored compounds. Transition metals are there and their many compounds act as a good catalyst. What are the interstitial compounds? Why are such compounds known for the transition metal? How is the availability in the oxidation state of the transition metal different from that of the non-transition metal? Illustrate with example. Describe the preparations of the potassium dichromate from the chromite ore. What is the effect of the increasing pH on the solutions of the potassium dichromate? Describe the oxidizing actions of the potassium dichromate and add the ionic equation for its reaction. Iodide, Rn and the H2S. फिर आता है कि describe the preparations of the potassium permanganate. How does the acidified potassium how does the acidified permanganate solution react with the ions SO2 and the oxalic acid? Write the ionic equation for the reaction. For M2 plus M and M3 plus M system and the electrode value for the some metals are as follow. Use this data on to comment upon the stability of the Fe3 plus in the acid solution as compared to that of the Cr3 plus or the Mn3 plus, and for the use with which iron can be oxidized as compared to the similar process for either the chromium or the manganese metal. Predict which of the following will be colored in aqueous solution: Ti3 plus, B3 plus, U plus, Ac3 plus, Mn2 plus, Fa3 plus, and compare the stability of the +2 oxidation state for the elements for the first transition series. Compare the chemistry of the actinide with that of the lanthanide with the specific reference to the electronic configuration, atomic and ionic phases, oxidation state or chemical reactivity. How would you account for the following of the default species? Cr plus is strongly reducing while manganese is strongly oxidizing. Cobalt is stable in the aqueous solution, but in the presence of the complexing reagent it is easily oxidized. The D1 configuration is very unstable in the ions. What is meant by the disproportionation? Give two examples of the disproportionation reaction in the aqueous solution. Which metal is the first three of the transition metal exhibit +1 oxidation state most frequently and why? Calculate the number of the unpaired electrons in the following gaseous ion: Mn3 plus, Cr3 plus, B3 plus, Ti3 plus. Which one of these is the most stable in the aqueous solution? Give example and suggest the reason for the following features of the transition metal chemistry. The lowest oxidation state of the transition metal is the basic, the highest is the amphoteric acidic. A transition metal exhibit highest oxidation state in oxides and the fluorides. The highest oxidation state is exhibited in the oxidation ions of a metal. फिर आता है indicate the steps in the preparations of the K2Cr2S1 from the chromite ore, K1O4 from the pyrophosphate ore. What are the alloys? Name an important alloy which contains some of the lanthanide metals mentioned in its usage. What are the inner transition element? Decide which of the following atomic numbers are the atomic numbers for the inner transition element: 29, 59, 74, 95, 182, 184. The chemistry of the actinide elements is not so smooth as that of the lanthanide. Justify the statement by giving some example from the oxidation state of these elements. Which is the last element in the series of the actinoids? Write the electronic configuration of this element. Comment on the possible oxidation state of this element. फिर आता है कि use the Hund's rule to derive the electronic configuration of the C3 plus ion and calculate its magnetic moment on the basis of the Spinozzi formula. Name the member of the lanthanide series which exhibit the +4 oxidation state and those which exhibit the +2 oxidation state. Try to correlate this type of the behavior with the electronic configuration of this element. Compare the chemistry of the actinide with that of the lanthanide with reference to the electronic configuration, oxidation state and the chemical reactivity. Write electronic configurations of the elements with the atomic number 61, 91, 181 and 189. Compare the general characteristic of the first series of the transition metal with those of the second and the third series of the metal with respective to vertical columns. Give a special emphasis on the following points: electronic configuration, oxidation state, ionization enthalpy, and the atomic size. Write down the number of the 3D electrons in each of the following ions: Ti2 plus, B2 plus, Cr3 plus, Mn2 plus, Fe2 plus, Fe3 plus, CO2 plus, Ni2 plus, and the CO2 plus. Indicate how would you expect the orbitals to be occupied for these hydrated ions octahedral. फिर आता है कमेंट ऑन द स्टेटमेंट दैट द एलिमेंट्स ऑफ द फर्स्ट ट्रांजिशन सीरीज पॉजेज मैनी प्रॉपर्टी different from those of the heavier transition elements, but can be inferred from the magnetic moment value of the following complex of species: K4MnCN6 2.2, Fe H2O6 2 plus 5.3 और K2MnCN 5.9. फिर आंसर टू द क्वेश्चन आता है कि फिल जेड बार 47 कैन गिव प्लस टू ऑक्सीडेशन स्टेट वेर इट विल हैव इनकम्प्लीटली फिल्ड डी ऑर्बिटल 4d, hence a transition element. In the formations of the metallic bond, no electron from the 3d metals 3d orbitals are filled in case of the zinc, while in all the other metals of the 3d free, electrons from the d orbitals are always involved in the formations of the metallic bonds. Manganese Z25 as its atom has the maximum number of the unpaired electron. Irregular variations in the ionization enthalpy is mainly attributed to the varying degree of the stability of the varying different 3D configuration. D0, D5, D10 are exceptionally stable. Because of the small size and the high electronegativity, oxygen of the fluorine can oxidize the metal to the highest oxidation state. Cr2 plus is a strong reducing agent than the Fe2 plus. Reagent D4, D3 occurs in the case of the Cr2 plus to Cr3 plus, but D6, D5 occurs in the case of the Fe2 plus to Fe3 plus. In a medium like the water, D3 is more stable as compared to the D5. Cu plus is aqueous solution undergo the disproportionation, that means Cu plus है जो Cu2 plus में और Cu में convert हो जाता है. The electrode value for this is favorable. The 5 F electrons are more effectively filled from the nuclear charge. In other words, the 5 F electrons themselves provide poor fielding from the element to the element in the series. तो यहाँ पर डी ब्लॉक है जो complete होता है.